So today I'm going to show you guys the expanded notation and go in a little more in depth and talk about partial quotients, and then use the inverse property of division, which is multiplication, to double check my work and see if it makes sense. You can do it two ways. You can do the rounding method of the inverse to check your work, or you can use any of the multiplication strategies we learned in NBT.6. All right, now expanded notation is similar to the standard algorithm, except you're finding partial quotients. So when we look for the divisor as 6, can it go into the thousands? No, because you can't evenly break up thousands. So we look at the hundreds. And now you have to add that 1,000 because it's still part of the value. So you have 12 hundreds. Well, knowing my facts, 2 times 6 is 12, and then I need 100, so 2 times 100 is 200. And I found my first partial quotient. When you find your first partial quotient of 200, because it goes into the 1200s, you multiply the 200 by the 6 to get 1,200, and you subtract to have a partial remainder. So our partial remainder is 72. Now, I don't know my 6 facts that well, but I know that 6 can go into 7 at least 10, at least 7 one time. So 60, subtract it. We have 12 as a remainder. How many times can 6 go into 12? We know that is 2. 2. And we get 0 remainder, so there is no remainder, and we add each partial quotient up, okay? This method is easy because normally you're separating the hundreds, tens, and ones, and we learned how to add that way since second grade. So you have 212 is your answer. Now, should we double check the work? Yes. What is one method to double check the work? You can round. 212 is close to 200. 6 times 200 is 1,200. Is that about close? Yes. Could you use the area model for multiplication, which is my personal favorite, but you can use any one you prefer. 200, 10, 2. 200 times 6, 2,000, which we did up there. 10 times 6 is 60. 6 times 2 is 12. Add those to get 1,272. So, with expanded notation, what you're really doing is breaking up the hundreds, tens, ones, maybe even thousands, depending on how you do it. I prefer to either check using a different division strategy or using that inverse strategy of multiplication. All right, I'm going to show you one more example that will look similar to the one you have for homework. That first one should too. 3,164 is going to be our dividend. And then we're going to divide it by 7, so 7 is our divisor. Okay, can I go into 3? No, so we need to go to the hundreds, 31. Knowing 4 times 7 is 28, and then we need to be in the hundreds, so we know the place values of the 400, so 2,800. When we subtract it, we get 364. Sorry. Now we need to think how many times. Well, 63. 360 is 36, and 7 goes into 36 50 times, because 50 would be 350. Subtract it, you get 14, and then you get 2, because you know 2 times 7 is 14. You get 0 remainder. You add all your partial quotients together to get 400 plus 50 plus 2 to get 452. After you added all your partial quotients, you should check your work. Now, I'm going to use the rounding method, but I'm going to round to the nearest 10, which is 450. 7 times 450. Well, 7 times 400... I'm going to use expanded notation, 7 times 400 and 7 times 50, 2,800, 350, add them together to get 3,150, which is close to our answer. If you wanted to do the 2, it would just add 7 times 2 to 14 to give you 3,164. Expanded notation is very similar, except you're finding partial quotients to standard algorithm, and you're looking in the place values. And using our different strategies for multiplication is a great way to check your work.